In this lesson, we are going to look at dividing fractions. We know that division of whole numbers, for example, 10 divided by 2, or we could write it as 10 divided by 2, means take 10 things and break them into 2 equal groups. What are we adding twice to get to 10, right? We want 2 things to add to get to 10. And we know that is 5. 5 plus 5 is 10. Therefore, 10 divided by 2 is 5, right? Or in other words, 5 times 2 is 10. They are inverse operations. So how are we going to do a quarter divided by 3? Well, we want to know what 3 things added together equals a quarter. So let's take a look on a number line and let's see if we can figure this out. So if we have 0, 1, 2 on a number line, and we want to place a quarter, right? Because this is our starting number in division. We start with a quarter, and we're dividing it into 3 equal groups. So now we're going to break this into a quarter, and we now have a quarter, right? That's 1/4. And we want to divide and know what 3 things added together equals 1/4. So we now further have to break that down into 3 equal pieces. So you can see that if we're breaking this into 3 equal pieces, we are finding a third of a quarter. And when we're finding a third of a quarter, that is multiplication, right? A third times a quarter is 1/12. So we know that each piece, meaning 1/12 plus 1/12 plus 1/12 equals 3/12, which is a quarter. So we now know, using this number line, that dividing by 3 is the same as finding a third of a quarter, which is 1/12. Okay, so it's kind of tricky. We're going to talk about a rule later, and once I give you a rule, it becomes a lot easier because you can follow a rule and get the answer. But before I give you a rule, I always like to make sure you really understand what the division means, so when we get to a word problem that you can understand, well, should I be adding these fractions? Should I be multiplying, or should I be dividing, right? If you want to break something into 3 equal groups, it's the same as taking a third of it. But what if you're dividing by a fraction, right? How do you make 1/8 equal groups? It's kind of confusing that way. So we could think about it this way, division. There's a few ways we can think about division. How many groups of 1/8 go into 3/4? How many times can 1/8 go into 3/4? Let's visualize this one in an area. So we're going to start with division. We always start with that first one. That's our total, right? We're starting with a total of 3/4. So I'm going to break this into 4 equal pieces, and I'm going to take 3/4. There we go. There we go. There's 3/4. And now I want to say, how many times can I take 1/8 out of the shaded, right? So I want to take 1/8 of the entire thing out of the shaded. So I want to break this entire thing into 8s. So right now it's broken into 4. So if I draw a line like that, it's now broken into 8s. How many times can I take 1/8 of the entire object, not just the shaded this time? We're not taking 1/8 of 3/4. We're taking 1/8 of the entire thing. I'm finding out how many 1/8 of the entire thing can be removed from 3/4. Well, I can remove 1/8 right there once. I can remove 1/8 twice, 3 times, 4 times, 5 times, 6 times. So 1/8 of the entire area can be removed from 3/4 of the entire area 6 times. Therefore, 3/4 divided by 1/8 is equal to 6. Okay, so gets kind of confusing, but this is basically knowing that 6 groups of 1/8 should equal 3/4, right? 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 equals 3/4 of the entire object. Let's try one more visualization before we get to a rule. This one's a little bit trickier. We're going to take 2/3 and we're going to divide it by 2/9. So we're going to start with 2/3. So I'm going to break it into 3 equal pieces, and we're going to take 2/3 of the entire object. And now I want to know how many times does 2/9 of the entire area go into 2/3. How many 2/9 added together give me 2/3. And so I need to break this into 9 equal pieces. So I've already got it broken into 3, so if I go across this way, I now have 9 equal pieces. So if I want to take 2/3 out, there's 2/3 of the entire object, right? Sorry, 2/9, I said that wrong. If I want to take 2/9, there's 2/9 of the entire object. So I'm going to take the 2/9 out once. I'm going to take 2/9 out twice. And I'm going to take 2/9 out 3 times. So we can see that 2/9 plus 2/9 plus 2/9 equals 2/3 of the entire object, right? So there's 3 groups of 2/9. So 2/3 divided by 2/9 equals 3. So what we have to do now is we have to try to figure out a rule that can get us this answer so we don't have to draw it every time, because division gets quite complicated, especially when your answer is not a whole number. It's kind of hard to figure out what it means. But basically, with division, we know that these two must multiply to give this. And so this is where mathematicians came up with a nice little rule. I'll show you where the rule came up, and if it doesn't make sense, it's okay. But it's nice just to try to figure it out and follow along, and then I'll give you the rule. As long as you get good at using the rule, that's okay. But I'll just go through the rule if you like. So if we have A over B, let's go, and we are dividing by, and I'm going to write my division like this for the sake of showing the rule, C divided by D, right? If we take A over B and we divide by C over D, we want to be able to get the answer. How can we get this answer? Well, remember, when we multiply the top of a fraction by, let's say, a number 2, and we multiply the bottom of a fraction by a number 2, you're really multiplying this entire big fraction by 2 over 2, which is just 1. So 2 divided by 2 is 1. So whenever you multiply anything by 1, you're not changing the fraction. And that's the key idea. So mathematicians, way back when they're coming up with a rule for what's the best rule? Because there's lots of different rules, but what's the best rule to maybe teach how to divide fractions? They said, okay, well, if we multiply the top and bottom by the same number, then we're just multiplying by 1 and we're not changing this fraction. So they said, well, I want to get a number 1 on the bottom. Because whenever you have a number with 1 on the bottom, it's just that number. 3 divided by 1 is 3. So how can I get 1 on the bottom? Well, if I have something like 2 over 3, and I multiply it by 3 over 2, right? You can see that I'm going to get 6 over 6, which is just 1. Or in other words, those cancel and those cancel, and we're left with 1. So whatever fraction you have on the bottom, C over D, you multiply by its reciprocal, D over C. Because the D's will cancel to give you 1. Whatever number they are, they're the same. The C's will cancel to give you 1. And you end up with 1 on the bottom. So whatever you do to the bottom, right? If I multiply by D over C, I have to multiply by D over C on the top as well. So this is going to give me A over B multiplied by D over C all over 1, which I don't need to write. So what the mathematician said is, okay, well, whenever you're dividing, like A over B divided by C over D, which I could write like this, A over B divided by C over D, that's the same thing, right? It's the same thing as writing it as A over B multiplied by its reciprocal. So that's the rule that we like to use and that most people have incorporated. So we're going to use that rule. So rather than drawing it out every time, we're going to say, oh, whenever we're dividing, we're just going to rewrite it as a multiplication question and multiply by the reciprocal. And again, if that doesn't make sense, that's okay. We'll just keep practicing with that, with the rule. So let's go to our rule. To divide fractions, we multiply by the reciprocal. So what is a reciprocal? Well, the definition of a reciprocal is a number that results in a product of 1. For example, if I have 4 over 3, my reciprocal gives me a product of 1. So what number should I put in there to give me a product of 1? Well, if I have 4 over 3, if 3 is on the bottom, I need 3 on the top. If 4 is on the top, I need 4 on the bottom. That way that they can cancel, right? So the reciprocal of 4 over 3 is 3 over 4. And it works every time if you just take your fraction and you flip the fraction, right? If you flip the fraction, you get a reciprocal. In other words, the product of 1. So what's the reciprocal of 2 over 5? The reciprocal of 2 over 5 would be 5 over 2. The reciprocal of 1 over 7 would be 7 over 1, which we don't write as 7 over 1. 7 over 1 is the same as just plain old 7, right? They're both. You can write either way. So 4, what's the reciprocal of 4? Well, 4 is the same as 4 over 1, so now I can take the reciprocal by writing it as 1 over 4. A little note to point out, just for extra, if you have the number 0 and you try to take the reciprocal of 0, you get 0 on the bottom, which is not allowed in mathematics. You're not allowed to divide by 0. It's an undefined operation. Therefore, 0 is the only number that does not have a reciprocal. So that's kind of interesting. So 0 does not have a reciprocal. It is undefined. And here's another interesting point. What's the reciprocal of 1? So take the reciprocal of 1 and you get 1 over 1, which just becomes 1. So another interesting point is 1's reciprocal is itself. So therefore, multiplying by 1 is the same as dividing by 1. They are the same thing, right? They don't change the question. All right, let's practice this then. So how do we use this rule? So if we have 10 over 15 and we're dividing by 5 over 6, we would rewrite the question. We would change it to 10 over 15. You'll notice the first fraction doesn't change. We change it to multiplying by 6 over 5. So we took the reciprocal of the second one and we changed the division to multiplication. Once it's in a multiplication state, we are now allowed to look for canceling before we multiply. You can't cancel in division, right? You can't do it because you're not doing 10 divided by 5 and 15 divided by 6. It's not what we're doing, okay? So we have to rewrite it as multiplication. Now we're allowed to cancel. So I can see, 5 and 10 cancels. And we can divide by 3. And now that we've canceled, we can multiply our numerators and multiply our denominators. All right, so let's review. Step 1 is rewrite as multiplying by the reciprocal. The first fraction remains the same. It's whatever follows the division sign that you write the reciprocal. Now that you have it in the reciprocal state and you're multiplying, you can now reduce. I find my greatest common factor that goes into both. And once you've done that, you can now complete your product. 7 times 1 and 3 times 5. All right? So it's really the same as multiplication. You just have to change it before you complete your multiplication. So a reminder, 17 is the same as 17 over 1. So you're going to rewrite it as 51 over 7, change it to multiplying by 1 over 17. Now that we're here, we can cancel, and then we can multiply. All right, this one's going to become 5 over 3 multiplied by 3 over 2. We're going to cancel, and we're going to get 5 over 2, which again, we could change into a mixed fraction if improper in the end, right? In other words, we know that 2.5 groups of 2/3 equals 5 over 3. Again, if we have the second fraction, we rewrite it as 9 over 1. What if I wrote it like this instead? Let's change this question. What if it was 9 divided by 18 over 15? What if it looked like that? Well, the 9 I would just rewrite as 9 over 1. And then I would change the division to multiplication, and I would take the reciprocal of this one. The 9 just stays as 9 over 1 because it's the first one. It's only what follows the division sign that you take the reciprocal of. And therefore, once you cancel, you say, oh, that's 1, that's 2. My final answer is 15 over 2, which becomes 7.5. Correct? 7.5 groups of 15 over 8 is equal to 9. Again, division can be written as a fraction, right? A fraction, so 3/4, this is the same as 3/4 divided by, which is the same as, make that over 1, 3/4 multiplied by 1 over 6. We do our canceling, which I know you guys are all getting really good at, and we get our final answer. Let's jump down to this one. I'm just going to show you that it's the same as 3/10 divided by 6 over 5, right? So you just write it as a division question, then you change it to multiplying by the reciprocal, and then you complete, right? And you get 1/4. If you have 3 fractions and they're multiplying and dividing, what I do is I rewrite everything as multiplication and then I look for my canceling. So if I wanted to rewrite this, the first fraction, I would just write as 3/4 multiplied by. It's already multiplied by, so I leave the 6/5 the same. It doesn't change, right? Only the fractions that follow the division sign. So here's my, there's only one division sign, so it's the fraction that follows that I rewrite. So it becomes multiplied by 15 over 2. So I can see that's the only reciprocal I take. Now I can look for canceling. A reminder, when you can cancel this 3 with this 4, 5, or 2. This 6 can cancel with the 4, 5, or 2. It doesn't matter where. I can see I can divide by 2, I can divide by 2. This 15 can divide by any denominator. So I can say, oh, look at the 5 and 15 can cancel, right? Goes in 3 times. I believe I have everything I can do there, and so I'm going to get 3 times 3 is 9. 9 times 3 is 27. Be careful, it's not 3 plus 3 plus 3. We're multiplying. And 2 times 1 times 2 is 4. And then you can go ahead and change that into a mixed if needed. All right. What happens if we have 3 fractions and they're all division? Well, now I have 2 division signs, right? So I can have to, this one is the first fraction that does not follow a division sign, so it stays as 3 over 32. I change it to multiplying by the reciprocal, and then I change it to multiplying by the reciprocal. So I had to take 2 reciprocals because there's 2 division signs. And then you can look for your canceling. And so I can see all of our canceling happening here. I think we did this question before in our multiplying one, so it looks very familiar. Divide by 7, right? I can divide by 3. I can divide these by 2. And then my final answer is going to be 3 over 20. All right, so what kind of word problems are division? A fitness circuit is 1/4 kilometer long. So this is how the total distance of my circuit, 1/4 kilometer. A person must repeat the circuit to travel this total distance. So sorry, this is my total distance. I want to travel a total of 5/6 of a kilometer, right? How many 1/4 do I need to do to travel this total distance? So this is, if this is the total distance, I want to take my 5/6 of a kilometer and I want to know how many, meaning division, how many 1/4 do I need to complete to get to 5/6. So that means it's division. You start with your total and divide by how much it is each time, right? And I want to know how many 1/4 do I need to complete to get there. So it becomes 5 over 6 multiplied by 4 over 1, do my canceling, and I'm going to get 10 over 3, which becomes 3 1/3. So I need to do 3 1/4 long circuits and then 1/3 of the 1/4 circuit, which is 1/12 of a kilometer, to be able to complete 5/6. But if I gave you 3 fractions and I asked for you to find the average, well, remember, the average, or in other words, the mean, arithmetic mean, is to add up each of the items and divide by how many you have. So you're going to take 1/2 plus 2/3 plus 3/4. You're going to add it all up and you're going to divide by how many you have. The only difference here is you have fractions. So when you're adding fractions, don't forget you need a common denominator. So my common denominator is going to be 12. So I'm going to change to a common denominator, times by 6, times by 4, times by 3. So now I'm going to get 6 plus 8 is 14, plus 9 is 23 over 12, all divided by 3. Well, we can rewrite this as a division question, 23 over 12 divided by 3. And now that it's a division question, or 3 over 1, we can rewrite it as a multiplication, 23 over 12 multiplied by 1 over 3. I don't see any canceling, so now I just multiply my numerators and multiply my denominators. So the average, or arithmetic mean, of those three fractions is 23 over 36.